scientists say we need to rethink how we dispose of satellites. What goes up must come down. Or at least, for satellites it should. A team of researchers completed an analysis studying the way satellites re-enter the Earth's atmosphere and burn up, including cases where parts of them survive to impact the planet, and found that the casualty risk exceeds a critical threshold, according to a study recently shared on a preprint server. The term, casualty risk, doesn't literally mean humans will be smashed by falling satellites, but there is an increasing risk of satellite collisions, which could hinder or even spell disaster for future orbital missions. And satellites that orbited without control could pose a danger to property or the well-being of some on the surface. In other words, it's time to rethink the way we dispose of satellites. Higher orbiting satellites can use lunar and solar gravity for re-entry. The number of human-made satellites launched from federal and private entities has increased at exponential rates since the early 2010s. And the continuing growth of major activities in space from SpaceX, Blue Origin, NASA, and many others have created a systematic congestion of specific orbital regions about the Earth. According to the study, the two most populated orbital regions are the geosynchronous orbit SO and the low Earth orbit LEO ones. The latter is a crucial region, since it enables comparatively low-cost accessibility for satellite operations, like remote sensing, Earth observations, and telecommunications. By contrast, the SO region offers weather forecasting, television broadcasts, and worldwide communications, since no single LEO satellite will be in the same relative position above the Earth at all times. But the rapid expansion of space activity has resulted in an increase in the number of inactive satellites still in orbit. Typically, the ones in LEO are disposed of via natural re-entry into the atmosphere, since atmospheric drag is sufficient to slow them into a terminal trajectory in relatively short timeframes without additional boost. However, satellites based in SO, medium Earth orbit MEO, or highly elliptical orbit HEO require more involved strategies for deorbiting. The European Space Agency runs SO missions end by adding another 146 miles to their perigee, most distant position in an orbit, which puts the inactive satellite into a graveyard orbit, according to the study. But the researchers suggest these higher orbiting satellites in MEO and HEO regions should be moved into a region where lunar-solar gravitational perturbations can create a long-term trajectory that will ultimately send the satellites into a natural re-entry vector. Of course, earlier studies have analyzed this possibility, but the destructive re-entry implies a need to assess each spacecraft's casualty risk, which the researchers investigated using a software suite called Phoenix. Phoenix is an object-oriented code that analyzes the re-entry and demise of spacecraft configurations by representing them as a combination of elementary-shaped objects, for example boxes, spheres, flat plates, disks, and cylinders. To calculate the on-ground casualty risk, the scientists combined the casualty area, the region where the satellite breaks apart, and its component parts dissipate or scatter, the landing or impact locations, and a dataset depicting population centers, called the gridded population of the world GPW. The Phoenix software also accounts for finer details, like the breakup conditions and altitude at which solar panels are destroyed, in addition to material properties. The scientists' results showed that in no case of SO trajectories analyzed were the casualty risks compliant with the 10-4 figure demanded by risk regulations, which means the application of design for demise techniques, or controlled and semi-controlled re-entries will be necessary to allow SO satellites to be disposed via re-entry. More study is needed, since higher temperatures at earlier stages of re-entry can break up satellites or spacecraft early, changing the area of potential landfall. But with major satellite networks continuing to expand at unprecedented rates, and more space stations entering orbit and a new space tourism industry taking shape, the need to responsibly design satellites to minimize the risk of collisions will be paramount for a sustainable human and technological presence in orbit.